How's everybody doing today? Good, awesome. As Eric said, my name's Andy Knight. I work at MaxPoint. Hey, MaxPoint. I'm going to be here telling you today that testing in Python is fun. So, quick look at our agenda. This is very much going to be more of like a survey type talk. I'm going to tell a little about me, why I'm up here talking. We're going to cover generic testing best practices. I'm not sure what the skill level in the room is. Maybe some are experts, maybe some are novices. We're going to create that nice base of understanding. So then what we're going to do is we're going to look at a series of Python test frameworks. We're going to go either until I run out of slides or run out of time. And any time remaining will be open discussion and questions. This will be a non-interactive lecture in the sense that I don't expect you to be on your computer typing along. This is meant to be an overview and a survey. If you want the slides afterwards, please let me know. Hopefully, though, I'll try to make it fun and interesting and exciting, because some people might think this is mundane, but I love this stuff. So, a little bit about me. I really don't belong at this conference. I am not a data scientist. I'm not even a Python guru. What I am is I'm a software engineer with a specialty in QA and test automation. I've worked at IBM, I've worked at NetApp, right now I'm working at MaxPoint, MaxPoint represent. And my career path has been very much focused on testing and test automation. And so I'm here to share my expertise with y'all. I'm very excited to be here. So just for humor, at this conference, when somebody says pandas, most people are probably thinking of that nifty number Python package. I'm thinking about these little furry black and whites. So, first question for the group here. How many of you write perfect code? Raise your hand. Oh man, we got some hubris going on. Question 1A, how many of the rest of you who didn't raise your hand think that the people who raise their hands write perfect code? Telling. Right, you know, we live in a fallen world. Nobody writes perfect code. I don't write perfect code. That's why I test it, right? I believe people write imperfect code. I want to try to mitigate that risk and find the problems as much as possible. And we all know it deep down. So, we know we don't write perfect code. We know we should be testing our code. Next question is, how many of you actually automate your tests? Mixed bag. I'm seeing about probably 40%, 30, 40%. To those who raise your hand, awesome. This is going to be an easy talk for you. For everybody else, buckle in because here we go. Let's talk about some foundations of software testing. There's a distinction between testing and debugging. When I talk about testing, I'm talking about a very formal process here. Testing is the process of validating product features and of identifying any product defects. A lot of times you hear about having test teams or QA teams. You hear about writing test cases, these step 1 through 10 procedures, hitting all these different variation cases, right? There's supposed to be results, pass or fail. You're supposed to be able to cover your code with what those results may be to make sure you're actually hitting all your execution paths. That's what we mean when we talk about testing. It's different than debugging. Debugging is the manual process of stepping through software code to find one-off programming errors, right? A lot of people think that when they're just like banging out some awesome pandas library, something, I don't even know what language, whatever, and all of a sudden they run it through the interpreter and it crashes. And they're like, okay, I got to figure out what's going on here. So then they write some print statements, or they change some variables, or they muck with the code a little bit, and they keep running until finally it works. And yes, that's right. That would be debugging. That is not necessarily what we would consider testing, right? Debugging is more of just fiddling around, hacky kind of thing. Testing is a formal process. And there's many types of testing. This is the story of my life on display, right? I'm not going to drill too much into the definitions of all these things, but there are whole careers in this stuff. Some of the big things to point out, the difference between manual and automated testing. Manual testing is you sitting at your computer actually interacting with the product, the software product, to make sure you're passing your test cases. Automated would be I'm going to write a program or a test script to do the things automatically for me, and I'm just going to push a button, it's going to go, or I'm going to set up a system that's going to run it automatically for me. Another big difference in testing would be exploratory versus planned, right? Am I going to have an explicit test scenario, steps 1 through 10, that I'm going to run through and I'm going to write a check mark next to each step that I pass? Or is it a situation where I'm going to dedicate a block of time with this product and just hit it with all the bad nonsense I can think of and just kind of meander through and use my expertise as an engineer and as a product user to try to find problems in it? Our talk is largely going to focus on automated testing, planned testing, and functional testing. Functional meaning I want to run some steps and verify a pass-fail result to make sure that the thing works. Because that's what we want with testing. We want to make sure that thing works. And we're going to look at different Python frameworks for that. So you're thinking, okay, awesome, right? I know I got to test my code. I know I got to be, formal about it so I don't miss any of my cases and I can communicate with people and all. But why would I bother to automate my tests, right? You're telling me I have to write more code for the code I just wrote. Seems like this is going to be a very large investment of my time. What if there's bugs in my automated test cases? Not only bugs in my code now, right? So why would I spend the time to do this? Number of good reasons. Primarily, you need to test the code anyway. You need to have those test cases to make sure it works. Why not take the extra step to automate it? Because automated tests can be rerun easily and quickly, right? Let's say you've got a manual test case that takes, like 15 minutes to run. Let's say you need to run this test case through about, 10, 20 times in a release, right? You can either spend 15 minutes each time you need to run it, or you can spend a little extra time initially to automate it, and then every time after that, it's just a push of a button. You save your time. They can be scheduled to run whenever you want, especially with integration or continuous integration environments. You hook it up to Jenkins or something. They can also be defensive, right? They make sure that you don't break the existing code when you add to it, right? If you've got a very large project, right? Let's say thousands or millions of lines of code, whatever, and you're adding a new feature to that. How do you know that your new piece isn't going to magically break something else somewhere in the system? Well, of course you know because your code is perfect. No, you don't know, right? I've seen spectacular failures in the most weird of ways. It's my job. Having that automated test suite behind you is protection, right? Because if you add the new code and you hit the button, all of a sudden you've run 987 test cases against the old stuff, and you've verified, I know I have full coverage here, and I know now every single one of those 987 is passing, even after I add my new feature, you get that nice, warm, fuzzy feeling. Or the opposite, you put your code change into your feature branch, and out of those 987 test cases, 23 have now failed. Oops. Good thing you haven't merged that into your main branches so that your changes that broke the old stuff are isolated. So you can figure out now, oh, hey, what did I break? Good test cases should tell you that right away. Some other nice things about automated test cases, they don't make mistakes when they run. They're going to run the same way each time. Ever been under pressure? You've run this test case 10 times before, but the 11th time you forget that one step, who knows what you missed? Human error. Oops. Automated frameworks can also print pretty results. Your manager comes knocking on your door. Hey, how'd that set of test cases go? No, here's the nice report. You see all these check marks? We're good. They can show code coverage, like I mentioned before, right? There are tools that let you see, oh, hey, I've hit this module, or I've hit these functions in this module, these functions in this module, but none of my tests ran functions in this module. Guess where you should be writing your next tests? Awesome. And also, just overall, they formalize your test approach, right? They're making sure you're dotting your I's and crossing your T's. So, how do we write good tests? We're all bought in. Yeah, I want to write tests, but how do I write good tests? Because there's a big difference between good tests and bad tests. Couple pointers. We're not going to belabor these details too much, but just some things to think about. Know the type and scope of your tests, right? Are you looking to make very simple unit tests, or are you looking for something that's going to trace through multiple steps in your system? Are you looking to test, your module that you've written, or are you looking to test maybe somebody else's modules that they've written that you need to make sure they integrate well? And from there, choosing the appropriate test framework and tools. Typically, a single test should focus on a single thing, right? If you have one test case that's very, very long and is checking 100 different things, and that test case fails, which of those 100 things failed? I don't know, maybe we should split that up so that your tests are more focused. So when something does fail, you know right away, hey, boom, it was feature A that just exploded, but B, C, and D are good. Also, just based on my experience writing lots and lots of test cases, you want to have the simplest, minimal setup, inputs, and configuration necessary to run your tests. The more input parameters you have, the more complicated and confusing it becomes, especially if you have to share it with somebody or share it with another team. You want to keep things simple and focused when you do your testing. When I write automated tests, I also like to write out my step-by-step procedures before I do any programming at all. One of the recommendations I've given folks is, okay, I know, I get it. You're hot and ready. You want to put your fingers on the keyboard and start banging out some Py code. Way to go. What I recommend for that is when you make your test case function, write comment lines saying, okay, step 1, I'm going to do this. Step 2, I'm going to do this. And then putting your code in after each one of those lines to make sure, yes, this is my test procedure. Another big one, separating common logic for test code into shared test libraries, right? We all know the copy-paste nightmare, right? Unfortunately, test automation is a sphere where a lot of people have all these good best practices for developing their product code, and then when it comes to writing test automation, they throw it all away. I don't know why. Because you want to make sure your tests are reliable, especially if you're doing something more of a continuous integration, continuous test type of environment. So good practices for regular code is good practices for test code. So abstract those libraries, those classes, those functions, make it shareable. Functional tests also should be deterministic, right? There should not be these random things that you don't expect to happen, right? Every time I run a test, I want to make sure I'm getting the same expected results. And also, leave no trace on your systems. This is like a Boy Scout principle. You're at the campsite, right? You got to clean up all the tent and whatever at the back. Same thing for testing. If you mucked up data on your system, clean it up. If you had to set up some extra processes, close them down. Leave no trace, because it's very easy to overlook those things. The next thing you know, your system crashes because it ran out of resources of memory or CPU or something. So, quick overview, good testing practices. So, now that we've got that under our belt, let's talk about some Python test frameworks, because that's why we're here. This isn't just the testing conference, this is the Python conference, right? Python has tons of good testing frameworks. I'm going to cover about 5 of them. There's more I could cover. I only have so much time. You only have so much attention. So, the first one I'm going to cover is probably the most basic one, unittest. Has everyone heard of unittest before? Raise your hand if you've actually used unittest. Awesome, awesome. That's the majority. So we're very familiar with unittest. It's standard Python unittest framework. How it works is it provides this test case superclass. And in that class, you can override setup and tear down methods for your setup and cleanup. You have test methods in that class, test underscore thingy, right? Put your test code in there. You have assertion methods as well, assert true or assert false. We'll look at those in a moment. Any of the methods in that class prefixed with test underscore are going to be identified as test methods and run as such. So we obviously, in this room, have a lot of experience with unit test. It's good for basic unit testing. It's there, it's easy, it's simple, no frills, no thrills. However, it does have some disadvantages. Every test case needs to be part of this test case, needs to be a test case subclass, right? So you are forced into class inheritance. For all y'all object-oriented programmers out there, that might make you flinch a little bit like, ooh, I'm trapped. Yes, you are. Also, it doesn't really support parameterized test cases. So everything would have to be hard-coded in those scripts. Word to the wise, if you're using Python 2, it is recommended to use the unittest 2 library instead of just the unittest library to get Python 3's advancements as backports. And for those who are interested, you can also add on XML report generation for your tests to integrate into systems like Jenkins, for example, to display your pretty results, using this unittest XML reporting module, which is separate, but you can import it. So how should my project directory look when I'm using unit tests? So at the top, we'd have our root project directory. Most of us are going to put all of our Python code in like a folder, directory, or something. Under there, we're going to have our product code, meaning the thing that we're actually trying to write, probably either in just .py files or in subdirectories for packages. Under there, the best place to put your unit tests, make a new package called tests. Put in a init.py file in there so it identifies it as a package, and then put files named test underscore whatever your feature product name is. And then in those files, that's where you would put your unit test subclasses. I also like to include a README. That's what that's there for. So, looking at a code example, it may be a little hard to see from up here given the lighting and all, but this is just your basic unit test subclass where we've got, as you can see, class calculator test, and I'm inheriting from unittest.testCase, which I imported up here. I have a basic setup method, which is creating a calculator class and saving it as an attribute of my class. And then I have two test methods down here. I have test add and test subtract. In here, you can see it's using that stuff that I set up. And it's also calling the unit test method's assert equals method to make sure that when I add two different numbers, that the answer I get for the value is what I expect to be 5. Same thing down here, except now I'm subtracting. I'm calling a different method. And I'm saying, hey, when I subtract them, make sure that the answer is 1. So obviously number 1 is 3 and number 2 is 2. And there you have it. Very simple Python unit test test case. Any questions so far? Silence is gold. Now, if you want to do that XML report generation that I mentioned, you can easily add a main and start using this XML runner, XML test runner, output it to a directory. That'll just enable it in your Python script. When you run that as an executable, not only will it run the tests, it'll print out your XML report. It's optional though. Now, running these tests from the command line, very simple. Change directory into your project root directory, and then you can run unit tests using the Python command. Run it using the unit test module. That's what this Python-m unit test option is for. And then you give the package path to the test case. So remember we had a package called tests, and the module's name was testcalc. That had that class we saw. That'll run all the unit tests that it can discover. You can also choose to run test case classes by name. So in the next example, we have the the same command, except now instead of referring to the module, I'm also including the test class name. So if you can have multiple test classes in one py file, but I can choose which ones I want to run. You can also choose to discover tests from multiple files using the discover option for the command. So let's say I have multiple test files, I just want to run them all in one blow. Boom. That's how you can do it. Then also, referring back to that XML example I had, you can choose to run your unit tests as they were any other Python script. You don't necessarily need to use the unit test module to do that. It'll run it as an executable. And if in the executable's main, you're showing the unit test runner as what I showed on the previous slide, it'll also run the unit tests. So that is how you run unit tests in Python. But wait, there's more. Unit test is only one of multiple Python test frameworks. It's the most standard, it's the most basic, it's probably the one most people know about. There's another one called doctest. Has anybody heard of or used doctest before? Not as many hands. Doctest is pretty cool. Let me ask this question. Have we heard of doc strings? Raise your hand. Everybody's got their hand up. We all know doc strings. What are doc strings? So those awesome strings you put on these things that you define. They could be module things or class names or like methods or functions, right? And they tell us, hey, this is what this thing actually does, and you can read it from your interpreter. Everything's great. What if you could write test cases in your doc strings? Mind blown. That's what doctest is all about. So what a doctest is you put basically these test commands into your doc strings using this arrow, arrow, arrow in the doc string text. And then you would write the command as if you were at the Python interpreter. So if you wanted to test that add method, it could be like arrow, 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 add parenthesis 2, 3, or parenthesis. The very next line under that is where you will put the expected result that you would see from the interpreter. So you would put a 5 there. What the doc test will do is it will pick that up, run it as if it were running an interpreter, and make sure that what it got is what you said it should be. Ooh, fancy. This also can do some XML reporting. You can use the same module as that. Now, as cool as this may be, I will caution, this is something you should probably only do testing for like small scripts and tools. Like I know a lot of the data scientists, they do a lot of hacky kind of things with Python. That's awesome. That's cool. You make the world go round. This would be applicable for that. If you're writing major software systems, probably not. I recommend doctest for small scripts, small tools, something where your testing only needs to be very light, get it out the door, all that kind of stuff. So let's look at this. Directory layout, not really much to note because your doc strings are going into your source files. So wherever your source files are, you can stick them in there. Alternatively, you can write doc tests in separate text files. If you want to do that, what I recommend is you create some sort of folder in your project directory called doctest. It doesn't have to be this, but I recommend it so you remember it. And then you can put your text files in there, and then you can shove the text file path into the doctest command. So here's a quick example. Subtract method. Turn A minus B. Okay, trivial, I get it. Works for this example though. Your doc tests here are going to be in your doc string. Put some description, and then those triple arrows, boom, boom, boom. You can see how I'm invoking this particular function. And I'm expecting that when I subtract 3 and 2, I'll get a 1. And when I subtract 2 and 3, I'll get a negative 1. Very lightweight, very quick to do, very easy to do. If we wanted to, we could add some runners to a main method inside that same module. may or may not be what you want to do. You can still run it from the doctest command, or you could run it as an executable. And if you wanted to generate that XML output, you could do it like this here as well. So example invocations of this, again, always change to your project root directory. And here are different ways you can run the doctest commands. If you've included that main method in your module, you can just run it as a regular executable, and it'll do your doc tests. If you don't have that, you can run it through the doctest module and just push it in. Notice here that these are file paths. These are not package paths. Different frameworks require different things. I've been burned on this before. Doctest is going to expect actual file paths. Something that might be tricky for you at first also, if all of your doc paths pass, guess what it prints? Nothing. That may make you think, did it even run my test? That's a good thing. It only prints by default if it failed something. But you can make it verbose with the -v option, so it will print that, hey, yes, you indeed did run your test and it was good. Same module call can be used to run doc tests in a regular text file, as shown here. And this was just an example showing, okay, it's the same invocation if you want to do the XML thing if you've got that in your main method. All right, let's look at another test framework, Nose. Who here has heard of or used Nose before? More hands than doctest, very good. Nose is basically like a better version of unittest, right? Nose has some niftier features. I think their tagline is Nose makes testing easier or something. That's basically what it does. It's nice. It's been around a few years. What's really nice about Nose is it lets you write tests either object-orientedly with a test case class or simply using functions. I like functional programming. I like functions. You're not tied into that nasty class inheritance thing. Awesome. So, Nose again works on discovery. You want to name your test case methods or test functions test underscore so that Nose will know, hey, this is a test case. Also, with that test case class, you don't need to inherit from any particular test case class. Like for unit test, remember you had to say, oh, I'm going to inherit from unittest.testCase. In Nose, you don't need any inheritance. They can just inherit from object. And it'll still be identified as a test case class. Why? Because it's named appropriately and it could be discovered. Some other nice things about Nose, they handle parameters using generators or Nose parameterized. So if you want to have the same logic, run different tests for different inputs, it's a little easier than unit test. It's also backwards compatible. Nose can run unit test tests. It can run doc test tests. So if you've already got many of those types of tests in your code repository, your framework, whatever, your code base, you can just start using Nose and use Nose to run those old ones as well to keep it all the same. Some warnings, not all plugins for Nose are compatible with Python 3. And also, Nose is not really actively supported anymore. So my recommendation would be use Nose more for legacy projects or to keep code bases that are using Nose going. Directory layout's pretty standard. The biggest difference between this and the one for unit test is that the tests should not be in a package hierarchy. They can just be flat directory system. Nose does not need to identify modules, or it does not need to identify modules as in some sort of package hierarchy, which is nice. You don't need that pesky init file. You can have it if you want, but it's not necessary. There's also this nose.cfg file. You can add extra options in there. You can either specify them on the command line, or you can provide them here. Things like generating XML reports. Do you want to capture output? All those sorts of things. I'm not going to drill too much into that. But the documentation online for Nose is pretty comprehensive. If we look at an example Nose test, you'll see this is going to be a little bit simpler than the unit test example. Here, we don't need a class, we just have functions, right? I import some nose stuff at the top. If I'm looking at a test add function, I'm just saying, hey, add these two numbers, and I'm using Python's basic assert statement to make sure it's good. What's nice about the assert statement, you don't need a clunky library, and it will print out this line to make sure that, okay, yes, when I fail, I know exactly where I failed. Nose also provides some nice built-in support for verifying exceptions, right? What if you're writing a function and it hits an exceptional case? Not for good reasons, but for bad reasons, and you want to make sure that it actually throws the exception, and the exception that you expect, and maybe the exception that has certain data in it. The raises attribute in nose will let you catch those exceptions instead of having to implement a try-catch block inside of your method. So if we look at some more nose examples here. This is an example of a generator in nose. This allows me to basically provide almost like a stream of data into one specific function to run multiple tests. So here, I have a function called test maximum. I want to test that when I run a maximum function that I'm actually getting the maximum value. So in my test generator function, I'm saying for basic for loop, for this tuple inside this list of tuples, yield the result, Python keyword, of some other function with some inputs. That other function is up here. Assert that the maximum is the number that I expect it to be. So this way, I have separated these out, and basically, I get 3 different test cases for the price of only 2 functions. So I don't need to hard code test maximum 1, test maximum 2, test maximum 3. That whole copy-paste nightmare. Yes! How do I launch nose tests? Even easier than unit tests. Change directory to your project, and if you just want to run everything from that directory down to be discovered as a test, just use the nose tests command. Running all tests in a module, you can specify that path. Running all tests, or running a specific test function, you can drill down to that specific function path. You can specify class names. And nose comes with a lot of options that you can build in as well. Now, you might be wondering, okay, so nose is great. I've used nose before, but you just told me it's not really being actively maintained. It's got a little bit of support lingering around, but the future does not look bright. Ooh, is there something better out there? There is. PyTest. Yay! PyTest is a mature, fully featured Python testing tool. It's actively supported, both Python 2 and 3, and is very, very similar to nose. Basically, I think Python or PyTest is like nose better for the present day. Same thing, you can write tests as functions or class methods. And the way PyTest does set up cleanup and all, they actually have a fixture framework for that, where you're basically passing around these subroutines to try to set things up or tear them down or set up directories. A bunch of built-in stuff there. A test can also be easily parameterized, much more easily than in nose. Assert statements are a little bit better as well, because you can use the basic Python assert statement, but PyTest includes some advanced introspection to make sure that everything is kosher and good and print out extra stuff for you. There's also a plug-in framework where you can extend PyTest. Directory layout is basically the same as nose. You can also have, of course you're not going to have a nose CFG file, you'd have this INI file that can specify certain things. One thing I will warn, make sure your Python path is set with nose. If you don't have it set to whatever directories or properly, you're going to find PyTest is not going to pick up your tests. I've had some people ask me questions about that. They've been very unhappy. It wasn't documented, so I want to make sure I pass the information on to you. Looking at a PyTest example, we can see similarities with what we saw in nose. Here we've got these test functions. The test add function is almost identical, right? PyTest can run nose tests. Backwards compatibility, cool stuff. Catching exceptions is a little bit different. There's this PyTest.raises that you use with PyTest raises and the type of the exception you want to catch. Attempt this, and this will evaluate to make sure, hey, did you actually catch this exception or not? This is a little bit more flexible. I think there's some more options in here where you can specify other things as well. And then parameterizing doesn't need that generator thing. What you can do is you can basically spill out, okay, I have a function, let's say test maximum. It's going to take in two things and an expected value. And I can just basically list in tuples, hey, when number 1 and number 2 are maximized, or you take the maximum of those two, you should get number 1. Let's reverse the order. Let's use the same number. Boom, boom. You can get multiple test variations very easily. Different combinations of input, same test logic here. No copy-paste nonsense. In order to launch your PyTests, again, command line stuff. Change directory to your project. Make sure you set the Python path correctly. To run all tests to be discovered in that directory, use the py.test command. Listing all tests with their results as they're run, add a verbose option. You can specify the path to specific tests, very standard, and you can also specify modules and all. I should mention this right now before I forget. I should have mentioned it sooner. Nose and PyTest are available for download through pip. You basically just say pip install nose, pip install PyTest. They'll install into whatever, either globally in your environment or virtual environment. And these commands, the nose test command or the py.test command, they're part of that installation. When the pip installs, it'll install these as command line executables for you. Granted, your paths are all kosher. So that's why those don't run Python something. They actually run a command line, which is Python under the covers. Some more examples of PyTest execution. You can generate that XML report. You can also do code coverage very easily with an extra module you can install. Make sure you get a report that says, okay, I've hit these lines and these paths and these modules. Very useful. And you can also print some help options. Finally, the last framework I'm going to talk about today is Avocado. Has anybody heard of Avocado? Some. Avocado was developed by Red Hat. It's actually pretty slick as far as test frameworks go. You can run tests written in any language, not just Python. The focus there seems to be Python, Bash, and C programs. When you write in Python, though, you want your tests to be subclasses of avocado.test. So again, we're kind of back in that unit test clunkiness. Everything's going to be an avocado test, not just a unit test. And in fact, I think avocado test inherits from unit test. Again, standard stuff. Each method should be named test underscore whatever. There's standard setup and cleanup methods. The outline and that structure is very similar to unit test. But there's a lot more that Avocado offers you. It has some special attributes, one of which is whiteboard. A whiteboard is going to be a string that's going to save. It's going to be saved automatically with test results. So let's say you're in your test and you're doing all sorts of awesome data, pandas, who knows whatever stuff, and your test just blows up in the middle and it just dies, right? And there was data in there that you would really like to know for debugging purposes. If you save it to whiteboard, that's going to be splatted out once your test is over, better or worse. Very useful. You can use it for other things as well. Also, there's a parameters attribute that it's a way for you to communicate from the outside, taking some test parameters that you want to pass in and then making them accessible to any test. There's also a log, which is convenient for logger. You can just print lines as you go to say, hey, I'm tracing this, I'm tracing this, I'm tracing this. Not all test frameworks have something like that, but it's very useful rather than setting up your own logs. There's other advanced features, almost too many to name. There's parameter multiplexing, where you can set apart different parameter scenarios. I guess it can go pretty deep, a couple levels. Test discovery, finding tests without having to explicitly name paths. Result formatting options. Job replay, if something fails the first time. Can I run it again right away? Or can I take an instance that was already run and run it under the same conditions? Remote test run, GDB, all that good stuff. One warning, it's Linux only. You can download the GitHub project, try to compile on Windows. I've never done that, don't know if it's going to work, but it is a Linuxy kind of thing. So, standard directory layout. Running out of time? Oh, okay, I'm out of time. Sure. So you can look up online for Avocado code, all that good stuff, running it. In summary, real quick, what should you use? Long story short, use PyTest. But each one does have their own unique benefits to consider as well. Thank you.